Now you just see probability of C1 less than P less than C2 is equal to 100 into 1 minus alpha percentage. This is what they are asking you to calculate. And you know that, what is that? Here, so, if we are taking a sample, x1, x2, so on up to xn is a sample. And this sample size is more than 30. Then only we can take it as a large sample. So whenever if you have a large sample, then the sample definitely follows a normal distribution, right? Definitely follows a normal distribution, right? Then what is the sample proportion? How can we calculate sample proportion formula? Can anybody tell me what is the sample proportion formula?
X by N.
X by n.
Yes, x by n. Okay, very good. X by n. X represents, now out of these n people, how many are possessing a particular characteristic? Divided by total number of observations. This is the sample proportion. We know that. Okay. And just now I told that if n is tending to infinity, that means if n increases, if the sample size is very large, then the observations follows a normal distribution, means the population proportion also follows a normal distribution. Right, everybody? Is it right?
Yes, ma'am.
Yes, ma'am.
Yes. So if P follows the normal distribution, then what is the standard normal variate? Z is equal to P minus, expect this is small p I'm taking, P minus expectation of small p by standard error of small p, which follows standard normal distribution. Why I'm taking here small p? Because population P only you need to calculate. Population P is unknown to you. You need to calculate. So for the sample proportion, what is the standard normal variate? You need to subtract with the mean and divide with the standard error. Okay. And what is the expectation of P and standard error? Did you remember? In the second unit, you learned that. What is the formula for the single proportion? Did you remember, anybody?
Yes, ma'am.
Tell me. Hmm.
P minus P naught by under PQ by N.
Yes, P by P minus P naught. Why I'm not taking P naught? Because here I'm not testing. If you're taking a hypothesis, we'll take a P naught. But here I'm not testing. That's why I'm taking a capital P. So PQ by N, which follows normal 0, comma 1. Did you understand what is the Z value? Is it
Yes, ma'am.
clear?
Yes,
Yes.
ma'am. Yes,
And
ma'am.
by the definition of the confidence interval, what do you need to find? C1 less than capital P less than C2, which is equal to 100 into 1 minus alpha percentage. This is what they have given. 100 into 1 minus alpha percentage means, can I write 1 minus alpha directly? Can I write
Yes,
1
ma'am.
minus alpha? Percentage is going to
Yes.
cancel. Then the remaining is 100, 1 minus alpha only. 1 minute. Yeah, this is 1 minus alpha. So you need to find what is the C1 and what is the C2. Okay, so here from the standard normal table, okay, from the standard normal table, we can find the limits here. What we are doing here, I'm writing that minus Z alpha by 2 less than Z alpha by 2 is equal to 1 minus alpha. I'm taking. Why I'm taking? Because here if the sample size increases, then the proportion definitely follows the normal distribution. So that's what, by using the proportion, we have written the capital Z. Okay, then Z is equal to, already you have a formula. So if it is a two-tailed test, why we are taking a two-tailed test? Because you need to find the left limit and you need to find the right limit. So if you need to find the two limits, then we are using the two-tailed test. So two-tailed test means alpha will be divided into the two parts, alpha by 2 for the left tail and alpha by 2 for the right tail. So from the probability, you can write this Z lies in between minus Z alpha by 2 and Z alpha by 2. Did you understand, everybody?
Yes,
Is it
ma'am.
clear?
Yes,
Yes.
ma'am.
Yes,
And
ma'am.
now you know what is the Z value, Z formula. You know that just now you have written small p minus capital P by under root of PQ by N. Have you written this? Did you know? Just now I have explained you, right?
Yes, ma'am.
Yes.
Yes,
Yes,
ma'am.
And
ma'am.
is equal less than Z alpha by 2 is equal to 1 minus alpha. Okay. Now, here this is equal to, here you just check it and see less than or equal to also you can take, or not taking equal to sign also no problem, because proportion anyway it is a continuous variable. Yeah. Now, after this, I want to know in between only the P. See what I want to know what I want, only the P value I want to know. Okay, so here what I have to do, I want to remove all these terms from this middle. In the middle, I want to make it as only the P. Then how can I remove that? You just check it. Multiply all the sides with a under root PQ by N. Then what you'll get it? Minus Z alpha by 2 under root PQ by N less than or equal to small p minus capital P, and less than or equal to Z alpha by 2 into under root PQ by N. See, listen here. Why did I write here P minus capital P only? Why I haven't written this part, denominator?
Cancel.
Yes, because you are multiplying with the under root PQ by N, so both are going to cancel. And now, here I want to remove this small p. Then what I have to do? What I have to do?
Subtract small p.
Subtract on both sides.
Yes, subtract small p. That means minus p should be taken. Okay, so minus p minus Z alpha by 2 under root PQ by N less than or equal to minus p plus p is going to cancel. Remaining is a capital P minus capital P less than or equal to minus p plus Z alpha by 2 under root PQ by N, which is equal to 1 minus alpha. Is it clear?
Yes, ma'am.
Yeah. Now here I want only the P, but here minus is there. Then what I have to do then? What I have to do?
Remove minus.
Yeah, how can I remove that minus?
Multiply minus.
Multiply minus.
Multiply minus.
Yeah, multiply with minus 1. So minus of minus P minus Z alpha by 2 into under root PQ by N. And whenever you are multiplying with the minus, the inequalities will be changing. So less than or equal to will convert it into the
Greater than or
Greater
equal
than
to.
Greater than or
greater than or equal to. So minus 1 minus into minus plus capital P greater than or equal to minus of minus P plus minus P plus Z alpha by 2 under root PQ by N, which is equal to 1 minus alpha. Okay, is it clear everybody till now?
Yes, ma'am.
Yes, ma'am.
Now
ma'am.
see, if I'm having A greater than B greater than C means, can I write C less than B less than A?
Yes, ma'am.
Yes, ma'am.
Yeah. Now here also this is I'm writing here, and see minus if I'm taking inside, what I'll be getting? P minus Z alpha by 2 under root PQ by N. Okay. And less than or equal to capital P less than or equal to minus into minus P minus into minus plus Z alpha by 2 under root PQ by N, which is equal to 1 minus alpha. Did you understand everybody? Is it clear?
Yes, ma'am.
Yes. Now you just check it, compare with this one, C1 less than or equal to capital P less than or equal to C2 is equal to 1 minus alpha. Now you just check it, what is the C1 and what is the C2? What is the C1 and
P
what is the
minus Z
C2?
alpha by 2 into PQ by N.
Yes, so C1, C2, what is the C1, C2? Minus P minus Z alpha by 2 under root PQ by N, comma, C2, small p plus or minus Z alpha by 2 under root capital P capital Q by N, which is equal, okay, this is known as the confidence interval. With what percentage? 1 minus alpha 100 percentage. Is it clear, everybody? And here, just see, this already you have, I think you remember this one. The confidence intervals we have written for the proportion. What is that? I told you that you need to take the small p plus or minus Z alpha by 2 into standard error of small p. Did I tell you this?
Yes, ma'am.
Yes,
So
ma'am.
standard error of p is nothing but PQ by N. Got the same thing? Got the same thing?
Yes, ma'am.
Yes, this is a way to find. Here, instead of doing all this derivation, directly I gave this formula in the problems, in the procedure. Okay. Is it clear, everybody?
Yes, ma'am.
Yeah. Suppose if I'm asking you to find the 95% confidence interval for single proportion. This is my question. Then what do you have to do? Think and tell me. Here, 100 into 1 minus alpha percentage is equal to, I'm giving 95 percentage. That means what is the alpha value?
5%.
5%. Alpha is 5%. So alpha is 0.05 means here what is the Z alpha by 2 at 5% level of significance?
1.96.
1.96. So in place of Z alpha by 2, what value you need to substitute?
1.96.
That's it. Okay, is it clear? Suppose if it is a 99%, if I'm asking, find the, sorry, find the 99% confidence interval. Then what do you have to write? After doing the complete derivation, what do you have to write?
Z alpha by 2 at 1%.
What is the value? Z alpha by 2 at
2.58.
2.58. Got it, everybody? Is it clear?
Yes.
So in the exam, they may ask you 100 into 1 minus alpha percentage, or they may ask you 99% or 95% or 90%. So if they ask 99% means here in place of Z alpha by 2, you need to take here the value 2.58. If it is a 95%, 1.96, like that you need to take. Is it clear? Is it clear?
Yes, ma'am.
Yeah, please. Now you just go for the, I'll give the notes to you, don't worry. Because it takes a lot of time if you copy. Then go for the second one. This is you just do. How many will do this? We'll check it. Right, that second question. Find 100 into 1 minus alpha percentage confidence interval for difference of proportions. What I'm asking you? Difference of proportions. Then what I have to find? Tell me. Probability of C1 less than or equal to C2 is equal to 100 into 1 minus alpha percentage. So what I have to take here in between?
P1 minus P2.
Very good. P1, capital P1 minus capital P2, difference of proportion. This is what we need to find. Is it clear? So here we are having a two samples, x1, x2, so on up to xn1 is a one sample which follows the normal distribution, because as n is greater than 30, and here y1, y2, y3, so on up to yn2. This is also another sample, follows the normal distribution with mean and the variance as sigma 1 square, mu 2 and sigma 2 square. Okay, this is also sample size is greater than 30. Then sample proportion, first sample proportion is x1 by n1 and second sample proportion is y by n2. Okay, you can take here x by n1 and y by n2. And then you know that P1 comma P2 also follows the normal distribution. Okay, P1 comma P2 follows the normal distribution. Okay, Jiva, millaga. Yeah, so variance of P1 minus P2. Okay, so here difference of this is P1 minus P2 also follows the same normal distribution because both the samples follows a normal distribution. Then what is the Z? What is the Z? Z is equal to what? P1 minus P2 minus expectation of P1 minus P2 divided by standard error of P1 minus P2, which follows a normal 0, 1. Tell me, what is the standard normal variate? P1 minus P2 minus expectation of P1 minus P2 is what?
Capital
Zero.
P1 minus capital P2.
P1 minus capital P.
Very good. Divided by standard error of P1 minus P2 is what?
Under root PQ into 1 by
PQ
N1 plus
into
1 by
1 by
N2.
N1 plus 1 by N2.
Very good. Under root PQ into 1 by N1 plus 1 by N2, which follows normal 0, 1. Now you just see, you know that by the definition of the standard normal probability, from the table we know that this Z alpha by 2 less than or equal Z less than or equal Z alpha by 2, which is equal to 100 into 1 minus alpha percentage. We know this one. Okay. Then you just check it. This is the definition of the normal distribution. So in place of Z, substitute this one. Okay. And remove each and every term simultaneously. And in the between, you just make it only this part only. Let me know what are the confidence interval. Will you do this? Yeah,
Yes,
from here
ma'am.
you just start doing. From here, everybody start doing. Let me know what is the C1, what is the C2. First, I want to know C1 less than or equal capital P1 minus capital P2, C2, 100 into 1 minus alpha percentage. So I want to know what is the C1, I want to know what is the C2. Do it fast. Make it fast, everybody, and let me know. జీవ నువ్వు ఆఫీస్కి వెళ్ళినప్పుడు ఒక పెద్ద ఇది బండల్ టేప్ తీసుకురావా టేప్ అది అతకు పెట్టడానికి ఆ ప్యాడ్ బ్రౌన్ కలర్ ఒక ట్రాన్స్పరెంట్ పెద్దది ఉన్నా సరే ఏదైనా పర్లేదు కానీ బ్రాడ్గా ఉండాలి అంత ఉండాలి Yeah, is doing, everybody is able to do.
Yes, ma'am.
Make it fast, everybody, let me know.
C1 P1 minus P2 minus Z alpha by 2 into under root.
1 minute, let me write. Yeah, what is the C1 comma C2, dear? Confidence limits,
P1 minus P2.
small p1.
Yes, ma'am.
Yeah, p1 minus p2
Minus
minus
Z alpha by 2 into under root PQ by
PQ by
PQ into 1 by N1 plus 1 by N2.
Okay, this is a C1. What is the C2?
P2 P1 minus P2 plus Z alpha by 2 into under root PQ into 1 by N1 plus 1 by N2.
Everybody got the same?
Yes, ma'am.
Yes, ma'am.
Could able to do? Confidence limits, everybody could able to do?
Yes, ma'am.
Yes, ma'am.
Yeah, this is what here, P1 minus P2 plus R minus Z alpha by 2 into standard error of P1 minus P2. Is that only?
Yes, ma'am.
Yes. Okay. Now, suppose if I'm asking, if, let me know 99% confidence limits for the difference of proportions in last sample. Then what is the C1, C2? What is the 99% confidence limits for difference of proportions? అప్పుడు C1 C2 values ఏమవుతాయి? What are the C1 C2 values? Don't know.
P1 minus P2 plus or minus 2.58 into standard deviation of P1 minus P2.
Yeah, in place of Z alpha by 2, you need to take 2.58. That's only. Just now I told you, still I'm not getting an answer from all the students. Only one student is responding. Very bad here. Suppose if I'm asking 95% confidence interval for difference of proportions in last sample, tell me.
P1
P1
minus
minus
Z alpha
Plus or
minus
minus 1.96 into
1.96
standard deviation of P1 minus P2.
Yes, very good. So in place of Z alpha by 2, don't see, this is only for your remembering purpose I gave you, dear. Don't write this in the exam. This is only you need to write till here. So here in place of Z alpha by 2, you need to write 1.96. Is it clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes. And now move to the third problem. I hope everybody is understanding, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, okay, we'll see what is the next one. Note it down. Obtain 100 into 1 minus alpha percentage confidence interval for parameter mu, for parameter mu, that's it. For parameter mu. Yeah. How many will say for this? We'll see that. Here, what I want to find probability of C1 less than or equal to mu less than or equal to C2. 100 into 1 minus alpha percentage. They asked you to find what is a C1 and C2. This is they asked you. Okay, and for which parameter? For mu they are asking. For mu means in which statistic will be there it is? In which test you are having this mu?
Test 3,
Single
ma'am.
mean. Just single
What
mean.
is it? Single mean. Very good. What is a single mean? Z is equal to X bar minus
Mu by
Expectation of
Sigma by
S
root
by
mu
root.
by, yes,
sigma
mu
by
by
root 10.
sigma by root 10. Okay, if sigma is unknown, then we'll substitute with the standard
by root
deviation S by root 10. Okay, which follows normal 0, comma 1. Okay, so here they are telling you that find the estimator for the parameter mu, confidence limits for the parameter mu. But did they mention whether it is a large sample or the small sample?
No, ma'am.
No, then what do you have to do? So you need to take two cases here. So what are the two cases you need to take? Here you need to take case 1 for large sample. Okay, and case 2 for small sample. Okay, for small sample, which test will apply, dear?
T test.
Test for
T
single mean.
test. Test for single mean means which test? F test, T test, chi-square test?
T test.
T
T
T
test.
test.
Okay. So for large sample use a Z test. For small sample use a T test. Did you understand?
Yes, ma'am.
Yes, ma'am.
Yes. And now we are having a sample x1, x2, so on up to xn, which is the sample size greater than 30. Last sample I'm telling greater than 30. So the sample has taken from the normal distribution with mean mu and sigma squared. Okay, then we know that x bar also follows a normal distribution with mu comma sigma square by n. Then what is a z? Z is equal to x bar minus expectation of x bar by standard error of x bar, which follows normal 0 comma 1, and which is equal to x bar minus mu by sigma by root n. Okay, which follows normal 0 comma 1. And now by the definition of the confidence interval, you need to find C1 less than or equal to mu less than or equal to C2 is equal to 100 into 1 minus alpha percentage. We have this by the definition of the confidence interval. So you need to find what is the mu for that is what are the limits for the mu, that is C1 and C2. What is C1 and C2 you need to find. Okay, so to find this one, we are taking the help of the standard normal distribution. So by the definition of the standard normal distribution, we know that Z value always lies in between minus Z value lies in between minus Z alpha by 2 and plus Z alpha by 2, which is equal 100 into 1 minus alpha percentage. Here you are giving 100 into 1 minus alpha. That's what here we are taking alpha by 2. Okay, now after this, in place of Z, substitute this x bar minus mu by sigma by root n. Okay, substitute that minus Z alpha by 2 less than or equal to x bar minus mu by sigma by root n less than or equal to Z alpha by 2, which is equal 100 into 1 minus alpha percentage. Now from this part, let me know what is the mu limits. Is it clear?
Yes, ma'am.
Will you do this, everybody?
Yes, ma'am.
Yeah, from here you just solve it and let me know. Let me know what is the C1, C2 for the mu. Do it, everybody.
C1 is x bar minus z alpha by 2 into sigma by root n.
Okay, 1 minute. Let me write. What is the C1 and C2? What are the C1 and C2 values? Mm.
X bar minus
Mm.
z alpha by 2 into
Mm.
sigma by root n.
Okay.
C2 is x bar plus z alpha by 2 into sigma by root n.
Okay. Everybody got the same?
Yes, ma'am.
Yes, ma'am.
Yes. I hope everybody understood how to do the confidence interval, right? Now, suppose if I'm telling that if sigma is unknown, then what is the C1 and C2? Tell me. What are the values of
X
C1 and
bar
C2?
minus z alpha by 2 into
Z
s
alpha
by
by
root
2
n.
into S
S
by
by
root
root n.
Very good. Small s by root n. Remember, small s by root n. Next. X bar
X bar
plus.
plus z alpha by 2 into
Z
small s
alpha
by
by 2 into S minus the root.
Okay. Understood, everybody? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes,
n. Yes,
ma'am.
ma'am.
Yeah. Is it clear, everybody? Or I'm getting answer from only few students. Everybody?
Yes,
Yes.
Yes.
ma'am.
Yes, ma'am.
Okay, fine. Thank you. Now, arre, 1 second. Okay, this is a case 1 is over, dear. Now tell me what is the case 2? What is the case 2?
Small sample t test.
Small sample, very good. If you have a small sample that is less than or equal 30, that means what I'm having x1, x2, so on up to xn is a sample, random sample of the size less than 30. Then, and it follows the normal distribution only. Then, the which test will apply for the test for a single mean? We apply the t-test. So, what is the formula for the t-test? X bar minus mu
X
by
bar minus
S
mu by
by
S
Capital S by
by
root n.
capital S by root n. Okay, yeah, capital S by root n. Fine, fine. Right, right, right. 1 minute. Let me change that. Yeah, capital S by root n, which follows what? T? T?
Minus 1
N
degrees of
minus
freedom.
1
N
degrees of
N
freedom.
minus
minus
1 degrees
1
of
degrees of
freedom.
freedom. Very good. Okay, you need to write this. Then, by the definition of the confidence interval, you need to find what is the mu, which is equal to 100 into 1 minus alpha percentage. So you need to find what are the C1 and C2 values. Okay, then how can you find? So by the definition of the probability distribution of the T, we have T lies in between this minus T alpha by 2 and plus T alpha by 2 with n minus 1 here. N minus 1 degrees of freedom, if you are not mentioning also, no problem. By this definition, it will be implied. Okay, is equal to 100 into 1 minus alpha percentage. Then now you just check it in place of t. T alpha by 2 less than or equal to in place of t. Take this one. X bar minus mu by S by root n, which is equal to T alpha by 2 is equal to 100 into 1 minus alpha percentage. Now do the calculation of this and let me know what are the C1 and C2 values. Directly you can see, you can say dear, without doing the calculations also directly you can
C1
say.
is x bar minus
X bar minus
T
T
alpha
alpha
by
by 2
2
into
into
capital S by
capital
root
S by
10.
10.
Very good. And C2?
X bar plus T
X
alpha by
bar
2
plus
into
T alpha
capital S
by
by
2
root
into
10.
S by root 10.
Is it right, everybody? See, simple thing dear. First ఇది మనం ఇది రిమూవ్ చేయాలి. సో మనం ఇది మల్టిప్లై చేయాలి. T alpha by 2 S by root 10. తర్వాత x బార్ తీసేసేయాలి. సో మైనస్ x బార్ పెడతాం. మైనస్ ఉంది కాబట్టి ప్లస్ అయిపోతాయి. అవును, అర్థమైందమ్మా ఎవ్రీబడి? డిడ్ యూ అండర్స్టాండ్?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
I hope everybody is understanding. Now, okay, next one. I'm not explaining anything. How many will finish this? We'll check it. Okay. Now. And remember, for t-test, sigma value should be unknown. There are assumptions. I hope you studied that. Assumptions are what? Population variance. Sigma is unknown. Then only you can apply the t-test. And see, 1 minute, you just remember this. If the sample size is less than 30. Okay, so less than 30 anagane to test for the mean, you think that we need to apply the t-test for mean testing. But here in this data, they have given you the population variance. They have given population variance is 2. Okay, then if the population variance is known to you, can you apply the t-test?
No, ma'am.
No. So if the sample size is small and population variance is known, then irrespective of the sample size, you need to apply the z-test only. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Now, move to the next one. This is the homework to you. How many will solve and show it to me tomorrow? We'll check it. Yeah. Find 100 into 1 minus alpha percentage confidence interval for difference of means. Difference of means. I hope you can do this one. Can you, everybody?
Yes, ma'am.
Yes,
ma'am.
ma'am.
So we'll check it. How many will do this? And tomorrow I'll start the next one. Single SD and difference of SDs in the small and large sample. We'll check it in tomorrow's class. Let me take an attendance. See, here also you need to do, what do you have to do? What do you
Large
have to do?
sample and small sample. two
Large
cases.
sample
good.
and small sample.
Very good, very good. You need to do both the cases, because here I did not mention whether it is a small sample or the large sample. So if they did not mention, means you need to find the limits for both the samples. Okay. Yeah. Let me take an attendance. In the meantime, you please do it. Our class is till 12:35, no?
Yes, ma'am.
Yes, ma'am.
You can finish it off, dear. Please do it. You can finish it off. Rule number 1. Rule number 8. Eleven, 12, 13. 19, 20. 22. 27.
Present, ma'am.
Oh, sorry. Rule number 30. $37, 39. 46. Monica, present? No?
Present, ma'am.
Yeah. Now tell me, what is for last sample? I'm asking in the last sample case, what is the difference of means test formula? Z is equal to
X bar minus Y bar minus
mu
mu1 minus
mu1
mu2
minus
by
mu2 by
under root of sigma 1 square by n1 plus sigma 2 square by n2.
very good. Sigma 1 square by n1 plus sigma 2 square by n2. Okay, fine. Now, what is the mu1 minus mu2 limit? What are the limits of mu1 minus mu2?
X bar minus Y bar
C1
minus
is
Z
X
alpha
bar
by 2
minus Y
under
bar
root S.
Okay.
minus
Hmm?
Z alpha by 2 into
Hmm?
under root of sigma
Hmm?
1 square by n1 plus sigma 2 square by n2.
Very good. What is the C2?
C2 X bar minus Y bar plus Z alpha by 2 into
Hmm?
under root of sigma 1 square by n1 plus sigma 2 square by n2.
Is everybody, is it right? Check it.
Yes, ma'am.
Yes, ma'am.
Is everybody able to do? Can I get a reply?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Thank you. Now for the small sample.
C1 is
C1
X
equals to
bar
X bar
minus Y
minus
bar
Y bar
minus Z
minus T
alpha by
alpha
2
by 2 into Sxy under root 1 by
X
N1
1
1 minute,
square
1
by
minute, 1
N.
minute. X bar minus Y bar minus what I have to take?
T alpha by 2.
T alpha by 2. Very good. Under root?
S1
Sxy
square
under
by n1 plus S2 square.
Wrong. What is the T formula, dear, for difference of means?
Sxy into under root 1 by N plus 1 by N.
Yeah, what is the X bar minus Y bar minus mu1 minus mu2 by what is the denominator? Pooled
SXY
variance.
Under root
Sxy
of
into under root
under root
of
of 1 by
1
n1
by
1
n1
by
plus
n1
1
plus
by
1 by
n2.
plus 1 by
1
n2.
by
Then how can you tell me S1 square and S2 square then? Then now tell me here, what are the limits for the small sample? X bar minus Y bar minus T alpha by 2 into,
Sxy
yeah, 1 minute, let me wipe this. Yeah, into, into Sxy into under root of 1 by n1 plus 1 by n2. And similarly for this X bar plus X bar minus Y bar plus T alpha by 2 into Sxy into under root, what it is, 1 by n1 plus 1 by n2. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Be careful. You need to write the first, what is the test statistic? And then from the test statistic, you need to write the confidence limits. Okay, is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah, tomorrow we'll go for the single SD and difference of SDs for the large and the small samples. Okay, with that, we'll finish our this part. Ante unda? Ante amma. Yeah, tomorrow we'll finish this confidence intervals. Okay, I hope everybody is understanding. Am I going fast for this? Can I get a reply?
No, ma'am. It's clear.
Yeah, thank you, dear. Okay, I'm leaving the class, everybody. Have a good day.